Alright, in this experiment, we did this in class, but I wanted to show it here in case you missed it. I've got three lights, a red, a blue, and a green, three different color lights, and what I'm going to do is uncover this piece of glow-in-the-dark plastic. I'm going to place these down on the plastic, directly on it. I'm going to leave them there for 20 seconds, and we'll see what happens. Alright, it's been about 20 seconds. Let's take these off and see what we get. So notice we have very bright glow, one that's more dim, and the red one was actually here and we get nothing. What this tells us, what this experiment told us, is that the blue light imparted more energy to the glow-in-the-dark plastic than did any of the other ones. So the blue light had the most energy, followed by the green, and then the red, with this red light has such low energy, you can put it here for as long as you want to, and you'll never get any pattern from it. So what we wanted to learn from this is the fact that blue gives us the highest glow because it has the most energy, followed by green, followed by red. So now we can relate those colors that we saw to the picture you see here on the screen. This is the visible portion of the entire electromagnetic spectrum. As you can see, we've got our good friend Roy G. Biv here: red, orange, yellow, green, blue, indigo, violet. Really, indigo is the same thing as the blue. They throw indigo in there so you get a nice word, Biv, at the end, but it really should be Roy G. Biv, BV. We call this the blue-violet end. We call this the red-orange end. The letters are in this order because this is in order of increasing frequency. But notice what the wavelength does. We have really high wavelengths on this end and they decrease toward this end. Because of the equation V equals F lambda, we know that the wavelength is inversely proportional to the frequency of these waves. So when we have really high wavelengths, we have actually low frequency, and vice versa. Low wavelength is high frequency. So on the visible spectrum, the blue-violet end is the highest frequency, the red-orange end is the lowest frequency, and then we can relate this to what we just saw in the experiment we did, which was that the blue light gave us the highest energy, followed by green, followed by red. And you'll notice that those are in order on this spectrum, and that's not an accident. And the reason is because blue, out of those three, has the highest frequency. Therefore, we can conclude that the frequency of light is directly proportional to the energy of the light. So if we have high frequency light, we have high energy. So blue-violet end, this is the high energy end of light. Red-orange end, this is the low energy end. Above violet light, out here to the other side of violet light, we get ultraviolet light, which is not visible from our eyes, but it is high energy radiation, as it can go through your skin and cause skin cancer, skin damage. And then on the other end, below red, we have infrared radiation, which is basically heat. They're infrared cameras that sense heat, which is infrared radiation coming from your body or the bodies of other animals and objects. So this is the visible spectrum. The point of this experiment that we did is to show that this is the high energy end, the blue-violet end. The red-orange end is the low energy end, and that corresponds with frequency. So frequency and energy are directly related, and it is indirectly related to the wavelength. High frequency is low wavelength, and low frequency means high wavelength.